Hey guys, I'm Pat Kelly. In this problem, they give us two complex numbers, and the directions ask us to find the distance between those two complex numbers in the complex plane. All right. What I'll suggest this really starts with is a formula that we have for distance. So you got to know your formulas. And this one equals the square root of s minus a in parentheses squared plus t minus b in parentheses then squared, and then close your radical hat. And yeah, that looks like pretty much any other distance formula if you see what's going on there. In the context of our problem, in order to use this formula, you really just want to make sure you know what to plug in for s and a and t and b. And where those come from are these complex numbers that they gave me. You need to be able to see this first one as a plus bi, and see the second one as s plus ti. So my s and a and t and b in the formula just come from each of the numbers that I see here in my complex numbers. All right. So this is going to equal, I'm ready to start plucking out of there and plugging into here. Parentheses, my s is -1, minus my a is just 1, parentheses squared, plus t, which comes from right there, the 4, subtract b, which comes from right there, that's a 2. And I'll pause for just a second. I'm okay on this problem, but I'm worried about you for other problems. I'm trying to grab b, which for me is 2, but if that had a subtraction sign right there, make sure you would have grabbed that -2 when you came over here to plug, okay? I'm all right for this one, just grabbing the 2 because it's positive there. But then back to the formula, close the parenthesis, square it, and finish off that radical hat. And now arithmetic. So square root. -1 subtract another one is -2, but squared looks like a 4, plus 4 subtract 2 is 2, but squared, that's 4. I'm looking at the square root of 8, which is actually 2 square root of 2 if I simplify. And I don't even want to bother with a decimal. I like that. That's your answer. Practice some on your own.